Alright, what's poppin'? In this video, you're gonna learn how debouncing React state can help you save quota on your database, make less unnecessary requests to your API endpoints, while also keeping a really solid user experience that is very responsive to user input. As an example for this debouncing concept, I'm gonna use a search input. The example is gonna be very clear. If you don't know what debouncing is yet, you're gonna understand it. And if you already do, you're gonna learn how to implement it properly in React. With that said, let's dive right in. Hey, so this is our React JSX component, and we're gonna take a look at how to make this more performant and more scalable using something known as debouncing. So let me quickly walk you through what this currently does. We have a state that we keep track of, which is the search results. And every time we type into this input field right here, this function gets run and awaits a mocked API query and then sets the search results to whatever we get back from that query, right? So the mocked API query is pretty simple. We are just waiting for 1 second to do nothing right here, and then returning this mock results array of whatever matches the current input. If we take a look at what that looks like in the browser, we have this field right here. And if I type in here, we can see, the names coming back kind of like in real time, depending on how many people of these mock response they match. The problem with this implementation is that it scales really, really badly. So take a look at this console, right? Each time I'm typing, it'll make an API request, and you'd see that in the network tab, if this was an actual network request it's making, but we're just mocking it. So take a look at this, John or Jane. Every time I'm typing one letter, it makes an API request, and that performs horrible. Just picture your database with 1 million rows. You perform a find many each time you type one letter. For each user, that scales horribly, and you're gonna be at your quota limit real fast. So let's take a look at how we can make this better, how we can implement debouncing to only send these requests when a user has stopped typing for more than a certain period of time. Usually that's 250 to 500 milliseconds, depending on how responsive the user interface is versus how much quota you want to save, how many requests you want to avoid. Now, let's take a look at how to implement this in practice, right? And we are going to use one library for that, and that library is called lodash.debounce. Let's take a look at that library in NPM. It's super convenient that it has a separate library because we don't need to install all of Lodash to use this debounce library. Lodash is a huge library and we don't need to worry about this. It has 19 million downloads in the past week. Lodash.debounce. It's kind of like one function taken out of the big Lodash and turned into its own separate library. To install this, we can take this over to the right or the left screen and then stop our server and say yarn add or npm install lodash.debounce. Press enter, and that's gonna install the dependency for us. That's all we need to worry about, and then we can start back up the server and start working with lodash.debounce to debounce our inputs and increase the performance of our component. Also, and what I forgot to do is we also want to install the types if we're working in TypeScript, because this does not come with types itself. So we can also say yarn add or npm install -d for a development dependency at types/lodash.debounce. Hit enter, and that's going to install the types for us if you're using TypeScript. If you're using JavaScript, don't worry about this, but it is going to make it a bit easier to work with this function in TypeScript. And then we can go ahead, start up the server, and let's get working in the code department. And the first thing we want to do is import the debounce that we can then use in our component. To do that, we can say import debounce from lodash.debounce. That is a default import or default export from Lodash, because that is literally the only thing this library does. It only debounces our inputs. And if you take a look at the current architecture with the input we have down here, the onChange handles the search, right? We have the handle search, and every time we press a button, this onChange gets called and executes the function that is inside of here. So the easiest way to debounce would be to declare a separate function. We can call this, and I'm going to disable GitHub Copilot. It's spoiling way too much information. We can call this debounced request, for example. And this is going to be equal to debounce, and this debounce is gonna wrap whatever function we want to debounce. And if we take a look at what we need the search term to make an API request. So obviously we want to pass it to the debounce function as well. Let's call it search term. It's gonna be of type string, and this function is gonna call the get search results, invoke that function, and pass along the search term that we debounced by. Now, the super convenient thing about Lodash.debounce is just like with a set timeout or set interval, the last argument this takes is a debounce by in milliseconds. You can see it right here. The wait of number or undefined, this is in milliseconds, and we want to wait for half a second that the user has stopped typing consecutively before we invoke this get search results function. Now, if we save this, nothing would happen because we haven't assigned this constant. And so instead of the handle search that we're calling, let's instead just call the debounce function. So this debounce function right here is going to get called every time we enter a new value and call this function up here, the get search results. So essentially we are completely skipping the handle search. And let's take a look at what that looks like in the browser. Let me move the original tab over here and let's type in J. And that made an API request. But if I type in multiple letters within 500 milliseconds, that is only going to make one request for the last 3 letters that I typed. So if I continue typing, it won't make a request. But if I stop typing for 500 milliseconds, what we said in the component, then it makes a request. Great. So this implementation works, but there are still some things we might need to fix or consider with this implementation specifically because it is not optimal. What if we wanted to keep track of the current input value as state, right? We would want to turn this input into a controlled component that has a value that is of the state and that always sets the state to its value, the e.target.value, whenever we make a change. In React, that is called a controlled input, so you always know what text is written in there in case you have a controlled input. Now let's make some modifications to this code to change this to a controlled input instead. Let's handle the onChange with onChange and then define a const onChange that's going to handle exactly that. If you're working in TypeScript, you want to type out the e event explicitly, and you can do that by receiving the event as the first parameter, hovering over it, and then copying the type into your function. And you probably also want to import that from React. And then you can get rid of the original e and just call the onChange. Okay, inside of the onChange, we want 2 things to happen, right? First off, we want to keep track of the current input value as state, so we can use it as a controlled input. Let's initialize the state, call the search term. That is going to be a string, and by default, that's going to be an empty string. If you are in regular JavaScript, you could just get rid of this generic, that's what it's called. Even if you're in TypeScript, you could get rid of that because it's going to infer the type from the empty string. I like them to be explicitly typed though. So first off, in the onChange, let's set the search term to whatever we receive as the e.target.value. And that's the beauty of typing this event out. We get full type safety in the onChange. And then secondly, we want a debounce function to happen. So we can say debounce request. And we also want the debounced request to happen with the e.target.value. And what we have done by doing this is getting rid of all the need for the handle search. However, there's still some functionality missing, right? Right now, we have no way to know what the search results are with this function because it is defined outside of the scope of the component and we are not setting any state from this function. So let's keep the handle search here just for a second. Before we worry about the search results though, let's turn the input into a complete controlled component, and we do that by also adding the value, and the value is going to be the search term. We can save that. Let's just have a little check that everything works. Let's reload the page and type in John. And as we can see right now, this is not ideal. Every time I type a letter, it makes a request, but it's delayed by 300 milliseconds or 500, whatever it is. That is not what we want. In fact, we need to make one more little change to get this to work properly. Let's initialize one final function and let's call that debounce request. And this is going to be a use callback. And what the use callback in this case does for us, it makes the function that is wrapped inside the use callback maintain identities across re-renders, whereas if we didn't have the use callback, every time the component re-renders, the identity of the function itself would also change. And inside of the use callback, let's receive the search term we want to search for as a string parameter if you're working in TypeScript, and then we want to make a request with this search term. And the last thing this use callback takes right here as the second argument or parameter, as I said, I keep mixing those up, is the dependency array. If you wanted the use callback to change the identity of whatever function is wrapped inside, this one right here, then you would put that in the dependency array. And now it's saying that the request doesn't exist. And what we mean with the request is this debounced request right here. We can turn this into a request, and then we also want to turn this into a debounce request, because that's what we call the use callback. And we're almost done. Last thing we need to do is declare this function right here, where we receive the search results as asynchronous. Because if we take a look at the get search results type, we can see that it takes a search term as a string and it returns a promise, meaning we need to await that promise. But if we try that right now, oops, and we don't want to get rid of the actual function call, if we wanted to await that promise, that wouldn't work. And to fix that, we can simply add a little async right in front of here, a cheeky little async, and that's going to allow us to await the search results. However, we don't want to just await them. Remember, we also want to keep them in state so we can display them to the user. And the way we do that is by removing this little one-liner and then executing a block, a function block, so multiple lines of code. First one being still the await get search results, and let's save that in a variable called results. Let's keep it in here, and as you can see, the type of the results is a string array, meaning we are awaiting whatever comes back from the mocked API call up here, receiving that as the results, and then because we want to keep it in state, we can say set search results to results. And just like that, we have gotten rid of all the necessity for the original handle search, implemented a controlled input so we can always know what the value of this input field is. Let's save our final implementation, go back to the browser and take a look at what happened. Let's reload the page. Let me type a J in here, and after 500 milliseconds, it made the API request. If I type multiple letters, it keeps making one request if I type multiple letters within that 500 millisecond time frame. Great, so this works really well. If I get rid of all of these, it's going to make one more API request. If I keep typing, it's not going to make a request until I stop for 500 milliseconds. And the big advantage of this implementation being that we have a controlled input where we keep the value in state instead of just having an uncontrolled input where we wouldn't know whatever the user typed in there if we need that in other places. Great, I really hope you enjoyed this video and make the best of it for your React applications. I'm gonna see you in the next one. Until then, have a good one and bye.